Hello, my name is Trupiano, and I'm going to be introducing to you the Consumer Matching Engine as a part of our CSI5450 Database Systems 1 project. My name is Trupiano, and I developed this along with my partner, Richard Frost. So, a quick overview of our presentation. First, we're going to go over our business rules. Then we're going to go over our ER diagram, then our query specifications, some data definition language, our project function and reports, and then we're going to go over a demonstration. So, what is a consumer matching engine? We're going to refer to it as a CME throughout this demo. So we've all heard these or even said these things ourselves, right? So many choices. What do I do? I can't find what I want. Do you have something close to what I want? And would you please help me pick? What would you do, right? We always want a second opinion or someone to kind of help us go through a decision-making process when we get, especially a big ticket item such as a car or a vehicle or something like a vehicle or a house. We are continually searching for complex items that uniquely suit us, such as cars or trucks, houses or apartments, and even relationships such as friendships or even dating, right? The CME helps us analyze items of any domain and recommends the ones that best match our unique needs and preferences. So by this means our consumer matching engine is built to be completely modular. So it allows the developer or the implementer to easily add any kind of use case through the user interface. So such as buying a boat, you can easily add a boat buying mechanism to the interface, and then the database backend logic does it all for you. So it's meant to be a modular project and a modular interface and implementator for choosing your match. And we're going to get into how that works a little bit later. So how does it work? The CME understands that all objects or people have features. The same type of object can have different values for each feature. People prefer certain values for a feature, such as the color of a car, the color of someone's eyes, etc. The importance of each feature varies widely by person. So, for example, someone would want a car with four-wheel drive and other people want it with two-wheel drive. Some people want to be in the Troy school district, others want to be in the Rochester school district. So the school system. So it varies based on the person. Everyone has different preferences. The CME understands some features are similar to others, and this is the entire concept of affinity. So affinity is the idea that, does the customer want silver wheels or aluminum wheels, right? If the customer wants silver wheels, aluminum wheels will be next on the list, up next to silver wheels, because those two are very similar. Now, brown wheels is going to have a much lower affinity value than aluminum wheels, and this is because they are complete opposites. Silver and brown are completely different, right? 4 bedrooms or 5 bedrooms. Those two affinity values will be very similar. However, 4 bedrooms versus 1 bedroom, those affinity values are going to be very different. So that's kind of how we define this concept of affinity. And the CME searches inventory and finds the best matches for a user. So that is all based on what they've selected for each feature, based on how important every feature is to them, and based on the affinity of different feature values that the matching engine has defined. So what are our business rules? The application is to remain modular and adaptable to different domains. Examples include finding the best matches on cars, homes, or even dating. The second rule is that the application should allow features and affinity for matching to be changed. The third is the feature selections and feature importance that a user makes should be saved and retrieved for the user. Fourth, the application will only suggest matches for inventory units that are available in the stock table for sale. And finally, last but not least, a user can use the system across multiple domains, and selections in one domain will not affect the selection in other domains. So the domains are completely sandboxed in this application. Here's our ER diagram. So this is a pretty self-explanatory diagram. It is completely normalized in 3NF. We've got our feature and feature value. So the feature, for example, would be, if we're talking about a car domain, a feature would be the body style. So do you want an SUV? And the feature value would be the types of body style. So feature you can think of as a kind of category. Feature value are the options in that category. So for a feature body style, I can choose SUV, minivan, sedan, etc. So that's how the feature and feature value work. In terms of domain, that is the universe of discourse that we're talking in. So the customer can choose which domain ID they want. One is for vehicles, the other is for homes, and the last one is for dating or friendships. And like we said earlier, the project is completely modular, so you can add more and more domains on as much as you want, and the project will adapt to those added domains. Stock talks about each item we have in stock. So all the vehicles will be stored in stock. Stock config is the configuration of the stock that relates it back to the feature ID. Customer profile, profile the customer. Has a composite key of customer ID and domain ID because domain ID is directly associated to what the customer wants and is used to query over and over again inside this database. Then we have customer, which is just the general customer with the name. And then the profile, like I said, is the more in-depth, which has all the features they want, all the domain IDs they want, etc. And finally, customer match. That is the end results table. That is the table that will contain the matches after the CME runs its calculations. It will store it in there, and then that table is eventually displayed to the user. So some query specifications. So this is where we create a customer profile, and then this is where we create that record inside our database. Pretty simple stuff. Now we have our creation of a view. So we use a SQL view for our affinity calculation. And this creates a table view which allows for easier calculation of the affinity value for a customer, instead of generating a complex table with multiple joins each time the affinity calculation needs to be performed. So for our match result calculation routine, this is the logic in these queries reads the customer desired features and properties that they selected in the customer profile builder, which we'll show you later in the video, and then calculates the points for each stock item. So you can pause the video and read through this, but that's pretty much what this query set of queries does. And this is all implemented step by step in a PHP script. And we also have a trigger. It's an insert trigger that finds ID for text values. So the user interface passes text values to the SQL code. It uses a before insert to look up the numeric key corresponding to the feature value. So we have the feature value name, which is, for example, SUV, but we also need that ID to pass it into our code for processing. So this is an update. So the interface puts in the feature value name, the trigger updates the table with the ID. So for some data definition language, this is for the domain feature and feature value tables. Pretty simple DDL for defining those tables with our foreign key constraints. This is the affinity table, a very important table for the relevance calculation. You can see we have our affinity foreign key with stock config value and feature value. So those are our two constraints there. Stock and stock config, we have foreign key constraints for domain ID. And we also have foreign key constraints on stock config for feature value ID and stock feature value. For customer profile, we have constraints for customer ID. For customer match, we have constraints for customer ID again. And like I said, this is where the entire thing comes together. So for our project core functions and reports, the customer matching profile, that is after the user selects their domain, they are then presented with a dynamic form that queries the database for feature categories and populates drop-down boxes with the values for each feature category. The next feature is customer best match calculation. Now this is also more of a report, but this feeds into the main report. Queries affinity, stock, feature, and customer tables to combine, calculate, and display data to the user with what their matches are. This involves many complex calculations, including the view we just showed you earlier that computes affinity. And finally, our report, which is the customer match report. This is the ending report that displays the most relevant matches for the customer based on the user feature selection, how they are prioritized, and the available inventory in stock. Now, we are going to go and show you our fully featured project demo. Okay, here is our project demo. You can see when the user enters the website, they are greeted with our homepage. So welcome to the Consumer Matching Engine. We've got a link where they can download the SQL file and you can load it into MySQL yourself to basically get up and running. You just have to have the local Bitnami LAMP stack like we were instructed to install, and then you can use these database credentials to access it. So you can run it all locally. It's not currently run in the cloud, but if this were to be implemented in an enterprise environment, we would ideally do that. So let's get started. Let's start the consumer matching engine. So here's our consumer matching engine. It's a step-by-step process, almost like a wizard. So first we're going to start by creating a customer profile. So I'm going to type in name, say Jason Jones. I'm going to say Jason is interested in buying a vehicle. Okay, let's submit. So as you can see, it stored the customer name in the database and their domain. So that's stored in the customer table. Now we're going to build the customer profile table. So you can see we have these values, and these are all dynamically generated from the database. There is no hard coding of any HTML elements. This is all taken right from the database, including all of these dropdowns. So we're going to set, this is the feature, we're going to set the feature value. Let's say he wants a sports car, that's high priority. He wants it to be red, that's also high. Engine, definitely V8, high. Transmission, he doesn't really care. And front wheel drive is medium. Okay, that's Jason Jones' selection. Now when we submit this for querying, it's going to do all of the affinity routines that we talked about earlier. So let's submit. As you can see, our results are in. So this is going to show the stock number that is available, the car that he wanted, and the total points, this is the affinity value, that were calculated. So obviously Jason Jones would want a Chevy Malibu. So that is the total affinity point for Chevy Malibu. And I'm sure if a sports car that was the right amount of cylinders that was in stock, it would be number one. But it's not in stock. So we wanted to demonstrate the relevance of the stock table in a customer match. So it will thank you for using it and ask you to restart. So I'm going to restart. I'm going to enter Joanna Jones. And she wants to find a home. Now, as you can see, these forms were loaded differently based on the database. So condo high, she wants 3 bedrooms, low priority. Let's say traditional, why not? Low. Urban is high. Okay, submit query. She got a 3-bedroom ranch in Romeo. That sounds good. 4-bedroom ranch, traditional colonial choice. So these are some more matches that we have here. Okay, that is all we have for today. Thank you very much for watching, and have a great rest of the semester.